Good morning friends. So today we are going to take up the second part of chapter 1, chemical reactions and equations of class 10th. So in previous class we studied about different types of changes and how to balance a chemical equation. So today we are going to deal with the types of chemical reactions. So there are basically 5 types of chemical reactions. So we will take up each of them one by one. So first is combination reaction. What does the word combination mean? It means that there is combination of materials substances taking place. So for example, suppose this is a reactant 1 and this is a reactant 2. They combine to form a product C. So here there are 2 reactants and 1 product. There can be more reactants, A plus, B plus, C plus D. They combine to form a single product D. These are reactants, 4 reactants, 1 product. So whenever 2 or more reactants combine to form a single product, then it is known as a combination reaction. We can take up some examples from real life. The first example is burning of coal. ठंडियों में हम कोयला जलाते हैं, right? Now look here. This is burning of coal. Coal is made up of carbon, so it combines with oxygen to form carbon dioxide. So this is a combination reaction. Why? Because 2 reactants are combining to form a single product. Formation of water, H2 gas plus O2 gas. This combines to form water liquid. This is a combination reaction, right? These are all balanced equations. Now you can see what is this man doing. This is magnesium ribbon. This is an element. This is magnesium ribbon. He is burning it. It burns with a dazzling white light. So a lot of heat and light is produced. Dazzling white light. So here what kind of reaction is taking place? Magnesium plus oxygen gives you MgO. You can balance it as I told you in the previous class. This is solid, this is gaseous, this is solid. So this is solid, it combines with air and forms ash. This is ash. What is this? This is magnesium oxide. So this is again a combination reaction because 2 reactants are combining to form a single product. Now we will study exothermic reaction as a subpart. Basically, whatever is the type of reaction, they can be divided into exothermic and endothermic. We can take 2 examples of exothermic reactions. C6H12O6. Do you know which compound is this? This is glucose. This is solid. This combines with gaseous oxygen and it forms 6CO2 plus 6H2O plus energy. So can you name this reaction? This is aqueous, this is liquid. This is respiration reaction. It leads to production of energy. Wherever there is production of energy in the form of heat, light or any other form, so it is known as exothermic reaction. So burning of coal is also a exothermic reaction. Respiration is exothermic reaction. Decomposition of compost. This is again a exothermic reaction. Right? If we talk about endothermic reactions, we will take up in decomposition reactions. First, look at this. This is second type, decomposition reaction. Now look at these reactions. You can see single reactant, but 3 products. Right? Iron sulfate, your ferrous sulfate, on heating gives you ferric oxide, sulfur dioxide and sulfur trioxide. So we can conclude, we can make a general equation. For example, this is a reactant. This is given heat, light or electrical energy. It can be any form. So it gives, it leads to breakdown of this compound and it forms 3 products, B plus C plus D. So here you can see 1 reactant, 3 products. Decomposition. Something is getting decomposed. It is getting breakdown. So A is breaks down into B, C and D. So these types of reactions in which single reactant breaks down to produce 2 or more products is known as decomposition reaction. One more reaction we can take. Calcium carbonate in the presence of heat gives you quicklime and carbon dioxide. 1 reactant, many products. Lead nitrate in the presence of heat gives you lead oxide, nitrogen dioxide and oxygen. 1 reactant, many products. So this is a decomposition reaction. So what are the different types of decomposition reactions? First, whenever you give heat to the reactant to split it up, then it is a thermal decomposition. Whenever you give sunlight or light, it is photolytic. Whenever you give electricity, it is known as electrolytic decomposition, right? So we will take some more examples to understand. Here, water, it is in liquid state. When you pass on electricity through the process of electrolysis, it splits up into hydrogen gas and oxygen gas. This is again a electrolytic decomposition reaction. Now we are going to discuss the most important decomposition reaction. It is used in black and white photography. What is the reaction? This is silver chloride. This is solid. This in the presence of sunlight. This is kept under sunlight. What will happen? This is white in color. It splits up into silver and chloride. Silver, it is grey in color, right? Silver metal is grey in color. So you can balance it parallelly. You can write 2 here, you can write 2 here. This is a balanced equation. Here also you can, above equation can also be balanced, right, like this. You can balance the equation by yourself. Currently I am focusing on the types of reactions. So this is a very important reaction which is used up in black and white photography. It takes place under sunlight. There is one more reaction. Silver bromide. This in the presence of sunlight gives you silver in the solid state and bromine gas in the gaseous state. Right? Now we are going to study displacement reaction. What happens in displacement reaction? Suppose this is a compound, this is an element. What happens? C is more reactive than A. So it can more vigorously react with B rather than A. So it displaces A from the compound AB and it forms a compound BC. Now A is removed. It is now single. Right? So this reaction, this equation, this displacement reaction is basically based on activity series. This series tells you about the activity potential of an element. This is a proper series. It starts with K. It shows all the elements in the order of their reactivity. Put K, N, A like this. There is a reactivity series and gold. This is gold. This is potassium. In this reactivity series, potassium is most reactive and gold is least reactive. We will see this series in a separate video, but here we can discuss some more examples. For example, iron. This is solid. CuSO4, aqueous. This reacts with iron. This is blue in color. Iron can be taken in the form of nail. What does it form? Now, in this reaction, iron is more reactive than copper. So it displaces copper from the copper sulfate solution. And what will be formed? FeSO4 aqueous plus Cu. So blue color, what happens? Fades. And there is a brown, this is brown in color. There is a brown coating on the iron nail. Brown coating on iron nail. Now we can take two more reactions. Zn plus FeSO4. This is aqueous, this is solid, and this is what happens? ZnSO4 is formed and iron is displaced. Why? Because zinc is more reactive than iron. But what will happen if we react copper with zinc sulfate solution? Will it react? Now copper is less reactive than zinc. So it will not be able to displace it from the zinc sulfate solution. So no reaction will take place. So this was displacement reaction. Now moving to double displacement reaction. Double means two. So two displacement are taking place here. Now we will take up this example. This is example. So this is test tube 1. It is having barium chloride. This test tube is having sodium sulfate. If you put sodium sulfate in barium chloride, exchange of ions takes place. Which two ions are exchanged? Sulfate and barium ions. These two are exchanged here. You can see here. So we can take with a general formula. Suppose this is a compound This is a compound. These are two ions which are to be exchanged. What will be the product? AC. This comes here and this goes here. So AC plus BD. So exchange of B and C are ions exchanged. So this is a double displacement reaction. Here you can find SO4 2 minus and Ba 2 plus. These are exchanged ions. So there is one more name of this particular reaction. It is also known as precipitation reaction. Why? A white precipitate. Here a white precipitate of barium sulfate is formed. This is solid. It forms a solid. It settles down in the aqueous solution of sodium chloride. So this is also known as precipitation reaction. Now moving on to last, oxidation and reduction reaction. We can see the definition here. Oxidation means addition of oxygen or losing hydrogen. Plus O or removing hydrogen. And reduction is just opposite. Losing oxygen or adding hydrogen. You can remember this by a mnemonic. Suppose this is LeO. Loss of electrons is oxidation. Loss of, this is electron, this is oxidation. This definition you will study in higher class. So leave it. We will take the simple concept. Now we will take up the reactions of oxidation and reduction. Right? The first reaction is, we already studied carbon plus oxygen, burning of coal. Here there is addition of oxygen. So which reaction it is? It is oxidation reaction. Now nitrogen plus hydrogen, it gives you NH3. There is addition of hydrogen. Then it is reduction. Now we will take up the reactions which show both oxidation and reduction. For example, CuO plus H2 gives you Cu plus H2O. This is copper oxide which reacts with hydrogen to form copper and water. So here you can see where oxidation is happening, where reduction is happening. This compound loses oxygen. Loses oxygen, find it. Loses oxygen means reduction. So here what is happening? Reduction. This compound is gaining oxygen. So this is oxidation. So this is getting oxidized. This is getting reduced. Right? We can take one more very important reaction. This is iron plus water plus oxygen. This gives you hydrated ferric oxide. Here no need to balance the equation because this can be any number. This is hydrated iron oxide. This is an oxidation reduction reaction. So sometimes oxidation and reduction both take place simultaneously, right? So this was oxidation reduction reaction. Now there are some practical examples of oxidation reduction reactions. So this is corrosion. What is the meaning of corrosion? I will write the definition for you. Corrosion is defined as destruction or degradation of metals, or we can say alloys also, by surrounding environment through chemical or electrochemical change. So we will analyze this definition. Suppose these are metals. This is iron, this is copper, this is silver. Whenever we talk about corrosion of iron or its alloys, we call its degradation as rusting. But when we talk about copper or silver or other metals, we don't use the term rust. We use the term corrosion. It is just degradation of the metal. Now see here, this is iron. Whenever you buy it from the market, it shines a lot. These are shining nails. But can you see there are some brown coatings on some of the nails? So what is this? This is nothing but the rust. We already studied this reaction. This is the reaction for rusting of iron. This is an oxidation reduction reaction, and this is nothing but the chemical formula for rust of iron. Right? Now if we look at copper, what happens in the case of copper? Copper reacts with water and carbon dioxide and oxygen, or we can say moisture and different gases in the air, to form copper carbonate and copper hydroxide. This is copper carbonate and copper hydroxide, right? So this is moisture, this is air, this is copper metal. Now what is this? What is the color of this corrosion? This is green coating, right? This green coating you can see, this is degradation of metal, this is corrosion of copper. Now if we talk about silver, now I am going to write reaction for silver. This is silver, it reacts with oxygen to form silver oxide. Then silver oxide finally reacts with hydrogen sulfide. This is aqueous to form silver sulfide plus water liquid. So these are the two reactions which occur when the corrosion of silver takes place. This is silver, you can see a black coating. This is silver sulfide. So silver is normally not affected by water and air, but it is basically affected by acids like hydrogen sulfide, right? So you can make a note here. Silver is affected basically by acids. not by moisture. So this was about corrosion. So metals of these compounds also get corroded or rusted. So how can we protect them? There are various ways to protect them. We can protect them by galvanization. We can put a coating of zinc, then painting, greasing, oiling. These are the methods by which we can protect the metal from getting corroded. The last topic is rancidity. Whenever we keep food in environment, it gives a bad smell after some time, especially in summer season. Bad smell and bad taste. The reason is it gets oxidated. Oxidation of food takes place. So how can we prevent the food which contain oil and fats? And there is a method. For example, this is, you can find a chips packet. It's very tasty, right? But how can you protect it for a long time? So these are packed with nitrogen gas. This is an antioxidant. It protects the food. It protects food from reacting with oxygen, and the food is preserved for a very long time. So this was the chapter first, chemical reactions and equations. With this we end the chapter. Now, thank you for joining me. Until then, revise from NCERT. Bye-bye.